Hey guys, it's Ian here from the eChook team again. I'm going to do a bit of a build video today to show you how to put together an eChook Nano version 1.2. Hopefully this is the kind of final version of the board. We've had some fairly good results with this. I think we've kind of learnt our lessons from version 1. Although this is backwards compatible with the same code, and all the same sensors and everything, I think it's just that little bit easier to put together, so hopefully students are going to be able to put these together themselves. So hopefully this video will help with that process. You can tell that you've got a version 1.2 because it's got the logo across here, and also all of the components should have their values labelled on there. Sorry, I've got a fairly slow focusing camera there. What you'll get when you open up your kit that we'll send out is something that looks a lot like this. So what I've done is just get that all out, spread it out on the table so we can easily see what we're going to put on, make sure all the components are there. Most importantly, what you will get is a whole load of resistor values, or resistors of different value. And it's obviously really important that the correct resistor values go in the correct component locations on the board when you're soldering it together. What we've done actually on this board, like I've shown you, is labelled all of the component values, and where possible, where there's a lot of resistors, you can see here written 1K on these resistors, which corresponds to these, 10K, 16K, 4K7, which means when you put the K in the middle, instead of being 4K7, that actually means it's a shorthand of writing 4,700. We've also got some resistors down here that I wasn't able to label in the packet. And what I've done before we start the process is just test those, just so I've got a good understanding. Obviously what you could do is read the resistor colour codes on these. And just try and zoom in on that. No, the camera's struggling too much on that. But we've got a yellow, purple, black, black. And then the final colour is brown, which is the tolerance of that resistor. So what I've done is I've selected ohms mode on the multimeter there. So we've got ohms, and then we're just going to carefully measure. So what I'm doing is I'm only trying to hold one probe with my finger. The reason for that is that otherwise my body's resistance does affect the reading slightly. So you can see that's 470 ohms or thereabouts. If I just put my body across that by holding with both fingers there, it does have a small effect, but this is a fairly low value resistor. On the higher value resistors, you'll notice the resistance of your human body making more of a difference to the reading that you get, so just be careful with that. So obviously I'm going to pop that one down. We've already marked that as 470. Just to give you an idea, this one I've already measured previously, it's 82K. So measuring that just without my finger across it, more or less 82K. If I put my finger across there, you really notice that value drop down, and you'll get yourself some fairly erroneous readings if you're not careful. So that's all the components. I'll get my soldering equipment set up and ready to start putting the board together. Okay, so now we've got all our components laid out, and what we're going to do is start by soldering the resistors onto the board. And the reason often we do the resistors first, they're kind of the smallest package, so they are probably easier to get into, certainly around tighter areas of the board up here. It's going to be easier to solder those in first, even though these are the more exciting kind of components to solder down, like nice big green connectors. So what we'll do is we'll get our equipment ready. So what we're going to do is start with a 1K resistor. So obviously pull that out of its cardboard wrapping. And then what I like to do, just come around. What I like to do from there is basically find one of the slots that's got 1K written on it, so I can see that R16 here is a 1K resistor. So I'm just going to carefully fold it so that it fits in there. Once we've done that, I can sort of get an idea as to how much leg to chop off. So I'll chop off, just leaving a little bit sticking through, probably 2mm there. Now what I find generally is a bit easier is if I can get the board to sit flat. And that's part of the reason why I put the resistors in first, because it means that I can use now the table to just hold that in position. So getting the soldering iron ready for our first resistor on the board. Apologies. So the general process of soldering, and hopefully you've got some adults that might have some experience in soldering. Generally what you want to do is you come up to the pad and you're trying to get the heat onto the leg and the pad, but you're going to apply the soldering iron, then apply just a little solder and leave the soldering iron there and remove the soldering iron. So the process is always that the soldering iron goes in first, then the solder, then take the solder away, then take the soldering iron away. And what you're looking for is a shape that looks a little like this. So if we have the hole here from the side with the leg coming up through it, you want ideally the solder to look a bit like this. This way you know you've got a good connection between here, here and here. What you sometimes see that's not so good if you use a lot of solder, or if you've not managed to get the heat onto the board, onto the pad, is you'll get a blob of solder on here, which may give you an intermittent connection to the board, which might give you some erroneous values. So it's got to be really careful to do this step right. So again, coming into that top leg and making sure I'm getting the heat into both the leg and the pad, applying that bit of solder, just leaving that iron on there for it to melt that bit more, then removing it again. Don't worry if you put too much on, because there are products that can help you take that away, like a solder sucker. You can always have another go again. Electronics is fairly forgiving like that, and that's part of the reason why it's so good to get young people into doing it, because you can always come back and change it and make improvements. Okay, so I'm ready to lay down my next resistor. I'm just going to try and show this that bit more close up. So I can see up here, R19, got another 1K resistor to put in. What is also important to note is that on this version of the board, what we've been careful to do is try and have all the components, so the resistors, the connectors, your LEDs, etc., are going to be on this side of the board, and you do all of your soldering operations on this side of the board that's got the logo on it. So obviously this is where we soldered before. Just try and give you a bit of a close-up of how that looked. Perhaps not. There we go. So you can sort of see there, you can get an appreciation for the sort of shape you want. And there are obviously lots of lessons online for how to solder well. This is really more specific to the eChook Nano build. What we've also got is, I think it's obvious here from the silk screen, that's the black kind of text lines where the resistors actually go, but I'll try and show this one a bit more close up. If I just grab another 1K resistor from the packet here, just pull that out. So I can see that R19 is the one I want to go for. So I'm just popping those legs into the two holes there. So you can see where I've popped that in there. It's a little bit off center. It would still work, but it doesn't look so good. So what we're going to do is just bend it and tweak it until we're happy with where it's placed. Straighten those legs out at the back a bit. So I'm much more happy with that, and you can always do a bit of bending anyway once you've soldered it. I'm just going to pop my finger on top of it, give it a turn over. And then you can see the legs have just popped through there. And I'm just going to cut those off. So I've got a little bit of leg showing. And I just sort of support it with my finger. Usually get a finger on the leg there that's just popping through. And I can get it back down onto the table. And you can just see those two legs there. Just indicate here. It's kind of this leg here and this leg here. And when you get more confident, what you can do is solder set up multiple resistors at one go, and then come through with your soldering iron. So again, the same process applies. Basically try and get on that pad and on the leg. Apply a bit of solder, not much at all, then remove. And the same again with that second leg. Again, it's soldering iron goes in, wait a bit, then you solder, and then remove the solder, remove the iron. What I've noticed on that second leg is I could perhaps have that a little bit more solder just to get the shape that I wanted. And there we go, that's good. So going back to the other side of the board again, you can see that resistor is now in place. You've had a little bit of solder come through to this side of the board. That's fine. That's just a better connection. So I'm going to continue and put the rest of the resistors on this board, and then we'll see how we get on from there. Okay, so now you can see I've gone around the board and populated all of those resistors. As I've said before, every component goes on this side of the board, so you're doing all your soldering on the back. Next up, over here, we've got some 1 microfarad capacitors. So we can see where they go on the board here. You've got C5 there showing 1 microfarad, C4 here, and C3 here. So what I like to do with these is to just cut the legs down just past that knee point there, and then we'll pop them in the board and get them soldered down, and the process is exactly the same. Now with these style of capacitors, they're called ceramic capacitors, and they're not polarized, so that's the same as the resistors. It doesn't matter which direction you put them in, so they always go in this side of the board, but left to right in this orientation. Doesn't matter which leg you put in which hole, and that's the same with the resistors as well, because they're not polarized. They will work the same no matter which way round they go. So again, I'm just going to pop that down on the table there. And the process is exactly the same as it was previously on the resistors. And you can see that is now on the board. And then I'll just do the other couple of those, and we'll get back to you. So I've got those 3 capacitors on there now. What I'm going to do is populate, I think, the PWM LED, which goes here. Now this component is polarized in a sense in that it will only work one way round. So what you've got actually, when you look closely on the LED, and it probably won't show up on the camera here, is there is actually a flat side on the plastic. So that flat side goes exactly where the flat is on this silk screen here. I'm just going to pop that through the hole. Again, same process as the resistors really, and the capacitors. Just cut off so you've got a couple of millimeters of leg showing. I'm going to pop it on the desk and get that soldered down. Okay. The next component I'll do, and just to mention all this brown here, this basically flux residue really shows up on these white boards. So when we're done, what I usually do is give it a bit of a clean with some flux cleaner spray or some IPA, just to neaten it up a bit, but it won't affect the final board. Next thing I'm going to do is another component where it's important we get the right direction. So this is the BC547, which is a transistor. Now what you can see probably on the camera there is, again, that's got a flat side on it, and the same procedure applies to the resistor. This has got 3 legs on it. You might have to slightly bend out 2 of the legs just to be able to pop it in the hole. But again, procedure is exactly the same, just a little fiddly to get all those lined up, especially while I'm watching it through the camera. You can see that that's just gone in there. Just push that down so it's nice and low down. It doesn't have to go all the way through, or all the way flush to the board. And then we'll just once again cut those legs off and get that soldered in. So we're really getting along well here with the board. The next thing I'm going to do is, again, another polarized component, and this is what we call an electrolytic capacitor. So usually find these in slightly bigger values than the ceramic capacitors we put on previously here and here. And you'll find that this has got a kind of grey line on it. They usually show the negative, so that's got like a negative symbol on it. So what I'm going to do is pop that in this hole here for C1, and we've got shown on the board in the silk screen there a plus sign, which you'll be able to see now on the bottom. So obviously what I'm going to do is take the negative leg and put it in the other hole. Okay guys, so now we've got the capacitor in, the next thing I'm going to solder in is this poly fuse. So a poly fuse essentially is a resettable fuse. So instead of blowing, if you accidentally plug the power in backwards on the eChook Nano, this should blow and it should heal itself essentially, so you don't have to replace it. So to do that, just gonna cut that off, just leaving a small amount of the leg showing. I tend to cut it off just above where the bend is in the leg. And then we'll pop that in FS1 on this corner. Might have to just push it through slightly, just so the ceramic goes into the hole. There we go. And then, again, normal soldering process, just to get it in place. A little bit difficult there because I cut a tiny bit too much of the legs. There we go, that's down. So next we have this component, which is basically a 5-volt regulator. So you can put in anything up to around 36 volts and it will regulate 5 volts DC out. So because all of the eChook Nano is running on a 5-volt power supply, this is what provides it. Can't really get this the wrong way around because it'll only fit in one way, but Again, another thing on PCBs that sometimes tells you which way around things go. You've got a square leg here, and that tends to denote pin 1, and on this component here you've got a dot that tends to denote pin 1. So we'll line those two things up like so. And that's quite easy because that's now the tallest component on the board. And what I recommend now is, because the board's on a bit of an angle, is I tend to solder just one leg first. Got one leg soldered there, and then I just check. You can see there's quite a gap there. That's just because I think we were standing on this cap. So what you can do, because you've only soldered one leg, is just get your finger behind it, just give it a push, and just heat that leg up. And then I just felt that push through, and there you've got a nice fitted component, which now means you can heat the other two legs up and solder those fully. There we go. So running out of components now, which is a good sign. This is a diode, so we use this to protect against accidentally plugging the eChook Nano in the wrong way around. I'll just move that out of the way. What you'll see on here is that there's sort of a grey band on this side. You need to match that up to this symbol. So a diode is inherently a polarized device in that it will only function correctly in the right direction. So unlike a resistor, you've got to get this the right way around, otherwise your reverse polarity protection won't work. So this line actually corresponds to this sort of symbol here. You can see it's got a line with an arrow through it. So you want to have it this orientation. Just going to fold the legs gently on that. Pop it through the hole, and much like a resistor now, leaving a couple of mil or so on the legs. Let's cut those. Now sometimes it gets a little tricky with components like this if you can't perhaps lay it down. So what I sometimes like to do is just get a bit of solder like that ready, sort of use it as a third hand. It's a little difficult to see what I'm doing here. Move things to the side. So what I've done is I've bent a bit of solder. That means that I can just sort of chase it against the soldering iron tip there. And if that's not the best joint, don't worry, you can come back and have another go at it. You'll definitely get a better joint on that second one. Now it's held in place. So just heat that up. Add a bit more solder if you feel you need to. And again, what we'll have to do is come back and clean this board up with a bit of flux cleaner, just because it does make a bit of a mess. But certainly depending on the type of solder you're using. Okay, so a few more components to do. Next up we'll go into how to cut these down. So we've basically sent in the kits with the boards a strip of this this dip rail basically. So we're using this for connecting both our Bluetooth to Bluetooth module, and the Arduino also goes on there. So first up, we'll cut it to size. What I tend to do is just take the Arduino out of its protective packaging, and then just zoom out slightly, and then I plug that onto here so I get a really good idea as to how long I need to make it. Don't have to count anything or get anything wrong that way. Then I get a sharp pair of cutters, and I'd be quite careful because I don't want to cut this too short. So if anything, I mean there is some extra pins on here, so if anything you want to cut slightly more to the right than you need to be. So I'm almost cutting over that next pin, which is fine. That's cut the pin out. There's a bit of excess plastic on there, but you haven't cut it too short, which is the important thing. Flip this around, plug it on there, and again do the same thing, almost cutting over the pin rather than the gap in between them. So that way you're definitely going to end up with enough there to hold the next pin along in. Once you've done that, we'll also cut one using the same sort of procedure for the Bluetooth module. You see that? Just give that a cut. That's sorted. So what I really like to do, and a bit of a top tip here, because we're using slightly, these aren't connected together in any way. When I solder this component onto the board, I like to keep it as one unit so that you don't end up with a big parallel kind of, having these misaligned, and then you wouldn't be able to fit the Arduino Nano in. So what I tend to do next is we'll pop that entire assembly in. You've got to be a bit careful here because there are a lot of pins to try and line up, so just take your time with it. Okay, so that's in there. You tend to find that stays in quite solid. But again, what I do with this, a bit like we did with the power chip earlier, is basically only solder one pin on each side, usually an end pin. If we go on here, just heat that up, apply some solder, and the same again on the other side. And then I'm just going to check visually that those connectors are nice and flush to the board, which I can see they are in this case, but you really don't want to end up in a scenario where it's lifted up, perhaps like that. So you can just, because you've only soldered one pin, you can just push it down. Then I secure it at the other end by soldering those pins on. Just give it one more check. I'm happy with that. So what I'll do now is just come along and solder all the rest of those pins. And take your time with that, you don't want to join any together by accident. So once I've done that, I'd normally go to this component next. So this is going to be our op-amp chip. It's subtle, but you can see that at one end of this there is a slight cutout just at this end. That's just to let you know where the top of the chip goes. And what you'll notice on the op-amp chip as well is, if you look at that closely, ideally with a better camera, there is a slight dimple just on this right hand side here. You'll be able to see that in real life, and that corresponds to the dimple on the socket, and there's also a bit of a dimple shown here in the silk screen. That's just to make sure everything gets plugged in the correct way. So this is pretty similar to the Arduino that we've just soldered down. So you're just going to get that in there. And sometimes, again, what I like to do is basically prepare a bit of solder there, just sort of dangling in the air, so I can at least use one of my hands to just hold the board and hold the component steady. And then I can, just for that one pin at least, just get a bit of solder on there. Just check again, it's nice and flat on the board, and then you can come back and solder the rest of those pins. I won't do that now. So the next step of the board, that's probably the easiest to do, are these big green connectors. So you're really coming towards the end of the build now. I'll show you with one of these 4-pin connectors. So we've got the current is a 4-pin device, so what I tend to do, just pop that in there. And now we've got quite a lot of components on the board, it's becoming more difficult to kind of hold things in place. What you might want to do is use a friend. You can use helping hands to kind of grip these in place. What I like to do really, if I'm just on my own, or if I'm being a bit lazy and haven't got the right tools out, just get a bit of solder on the end there, and you can sort of feed, with a bit of practice, feed that in to at least get one of those pins set solid. You might want to come back and just resolder that, and that's fine. What I tend to do then is, like the last few components, is just check that that's flat on the board, it's not skew width, because this is your main chance to do it where you've got one pin in, because if it was, you can just heat that up again. That's nice and easy. As soon as you get all 4 of these pins down, it's going to become a lot harder to heat them all up. One thing I recommend with these is they're quite big pins, so there's quite a lot of thermal mass there to heat up, so you really need to certainly get a good contact on there with your iron. Make sure you heat up both the pad and the pin, and feed in your solder. And if the solder flows nicely, you know you've done it. You know you've heated it up well. So just doing that all the way along. And I'm just going back to that first pin just to make sure I'd heated it up enough. It's a little bit difficult always when you've got to hold things at the same time. And there you have it. That's your connector. Sorted. So the final step of putting the eChook Nano board together is obviously I need to solder the rest of these pins on, but you'll do that at the time. You obviously solder on the rest of the connectors, but it's all the same as this first connector that we've just done here. The last step is just getting this Bluetooth module in place. And this is a little tricky, so we are looking into changing possibly the way we connect this on. We've already cut a strip of header to go on there, and we've got this ribbon cable. So it's got six wires in here. What I've already done is basically taken my cutters at one end and cut that into individual wires, just so I've got a little bit to play with. And then I'm going to basically what we call tin those wires, and that's the same sort of procedure as we've been doing on the board. So you just get your iron on the wire, heat it, and add some solder. And those are now what we call tinned. Again, we're going to tin the header, and that might be easier to do with the Bluetooth module on, just to give you something to hold. So you're just applying a little solder on each of those. This is quite hard to get neat, so sometimes what I do, just to make this really robust when I'm finished, is just come back and go over it with a blob of hot glue or something, just to keep it all together. Now this can be quite tricky on your own, so you may need a friend to help. So what I'm doing is basically the Bluetooth module is holding the connector steady, and then because we've got a bit of solder on each of those, you can just tend to heat that up. You may need to add some extra solder on in some cases, but because if you've got enough solder on the wire and on the pin itself, I tend to find that works quite nicely. So it can be a little difficult at this stage. Like I say, we are looking into getting some of these wire or some of these cables made up to go out with future boards. Just notice that that's a little dry on that joint there. Just put a little more solder on that. So what you might want to do is then come over this, just give it a bit of strain relief by folding that up on there, and applying a bit of hot glue or epoxy or something around that area, just to make that a nice solid connector. Okay, the same sort of procedure applies to the other end. You're going to cut that, going to strip the wires, tin them, and then basically they insert through the board here. And what you can see, in order to get this the right way round, is that the Bluetooth module and the silk screen on the board basically show you which pin goes where. That makes things reasonably easy. Obviously you've got a red trace wire here, so you can see that the red trace wire goes to enable the way I've soldered this round. So when you solder it, you'd obviously make sure that you get it this way round when you do that. Other than that, there are some sensors to set up, but we've got some other videos on those and other videos to come when you've got a completed board. it should look something a bit like this. Well, I'm missing a connector on this one when I made it, but yeah, it should look quite a lot like this. This is one I've cleaned up, so you can see obviously we've got the white back on the bottom there. And then once you've completed this video, I suggest you head on over to the documentation, and we will be releasing more videos, but there's instructions on checking before you turn anything on these test points here, just so you're not going to blow anything up, not going to damage your eChook Nano. I hope this video has been useful to you, and we'll chat soon. Thanks, bye.